It's a pleasure to be here. And what I want to do today is take you through about, I guess it's about 10 of the studies that I did of the 23 that led to the discovery of human pheromones. And if you get interested enough, I hope you'll go back to our website, which is athenainstitute.com, and this is its homepage. And on the homepage, you would click on the center thing, pheromone discovery, slide down to the published science, and that's where we're going to talk from. And go over to Ursinus College. We put this up special for this class because we're upgrading our website and we wanted you to have a carousel that we couldn't get on the earlier version that's not yet updated. So we're going to start with the study. These are the first group of studies. We're going to start with infertility and age at first coitus. And while that's coming on and while Jill is getting the tables that we're going to look at, and I only have about 3 minutes to study, so I can't tell you how we gathered the data, but you can read it, how we statistically tested the data, but you can read it, how we made sure that when we were asking intensely private questions about the sex life of women, how we assured that they would want to answer the truth by assuring them that they had privacy and the data were being collected in a double-blind fashion, so that the woman who kept records never met me and never produced her data for her student who was collecting the data. She'd put her on, this is before internet, she'd put her data in an envelope, seal it, and send it in to me with a code name. So those kinds of measures we were always doing because the privacy and security that a person feels about their data probably affects their willingness to be truthful about their data. And they all knew that they were making contributions to knowledge, which you're going to see. So I'd ask you to think about these 6 or 7 questions. Do you know what is a hormone? And what is a pheromone? What is a cycle? And what is the annual cycle? Who knows what the annual, how many days are in the annual cycle? Can somebody call that out? Name the number? Nobody knows the annual cycle. How long is a year? Can you tell us? 365 days. And do you know what causes it to be 365 days? Does anybody know that? Do you know? Why is it 365 not 200?
Earth's rotation.
Very good. It takes the Earth, not the Earth's rotation, it takes the Earth that many days to rotate around the sun one time, every 365 days. How about the lunar cycle? Does anybody know how long that is? I'm going to call on you if nobody calls it out, so be ready. You tell us.
A month.
What's a month? How many days?
30 to 30 minutes.
No, but almost. Does anybody else take a guess?
29.
Close. 29.5 is the amount of time it takes for the moon. And you know what tonight is on the moon? The major moon cycle tonight? It's an interesting issue. Okay, let's talk about what is a species. Does anybody know what a species is? The human species, the canine species. How do you define a species? That young man back there, do you know how you would define a species? The one who's looking away from me. Yeah. Do you know how you define a species?
Like a specific group of an animal.
What do they have in common? I'm going to tell you, if nobody else knows. It's a reproductively isolated group whose progeny match them. They have sex together and they produce of their own kind. So the human species doesn't have sex with dogs and produce something between a dog and a human. Only can successfully be fertile with its own kind. That's a species. And what does it take for a species to survive, to reproduce? The answer is fertility. So we're going to talk about fertility cycles. And what is the life force? Does anybody know what the life force is? One word? Lust. That is the life force that drives the reproduction of species. So that's an important word to understand. It has great power and great danger. So it's a very powerful concept. And the next and final really point is critical periods. When I was at Penn in my first year in biology, There was John Smith, who loved birds and bird song, and he taught about bird language, and I was enchanted with what he was teaching. Birds have a language. And he taught us that for a species, all the songs you hear in the morning at 4 and 5 in the morning, they're mating calls, most of them, and they're calling each other. Come to my nest, come mate with me in the spring. And what happens is there's a critical period for the onset of a baby bird to learn its species-specific song. And if it doesn't learn its song, if it's isolated from its parents and from its song, it will never reproduce when it grows up. So there are critical periods that I learned about, and now I'm going to show you about the critical period for coitus in humans. And that's where we get to start with these studies. The first study I'm showing you is, it came out of 792 women who had records in a major infertility center at Penn. My mentor, Celso Garcia, who was one of the 3 who was credited with inventing the oral contraceptive that liberated women from unwanted pregnancies if they were willing to take the pill, was my mentor. And when he saw the initial data I had, he said he would take me on as a graduate student and help guide my research. And we co-authored a great many things together. So I was learning about critical periods, and he had a major infertility service at the University of Pennsylvania's gynecology department, where people who had been to their physicians in hopes of getting pregnant and couldn't came to him because his group was the specialist. And I suggested we look at when they started having sex because I had just learned about the birds. And he said, that's interesting, let's do it. We had a bunch of students who came in and went through. Every day we would take out piles of paper records, sit around desks, record the data of when each woman had recorded her first coital experience, at what age. And what we have here, let's go to the next table. This is the first table that you should look at. There were 792 women. 314 of those women had a diagnosis of primary infertility, meaning they had never been able to knowingly conceive a pregnancy. The 478 had not primary, and the mean age at first coitus was statistically significantly different between the 2 groups. The women in the primary infertility group had had a first coital experience at 20 and a half years old. The average first coital age at the time was way younger. And these women had waited apparently past a critical period. That's what we were thinking. The next table breaks those groups into 6 different groups from no detectable pathology, there's 171 of them. Primary infertility, they can't find anything wrong, no detectable pathology. They had the oldest first coital age. The far right are routine gynecology patients. These would be people at the hospital at Penn or staff or faculty who said, this is a great physician, I want to use this group for regular routine gynecology. They had the youngest first coital age, and it was almost like a stepwise ladder. Let's go to the next table. And this looked at, no, I think we just did that. That's it. We're done with that study. Let's go to the next one. I think we did it in 3 minutes. We're going to go to sexual behavior frequency and menstrual cycle lengths. Okay, there's the first figure 1. There are 60 dots here, and those represent the data of 60 different women. When I started at Penn, I was a psych graduate student, and we were studying about the autonomic nervous system. Have you all had some exposure to sympathetic and parasympathetic nervous system? I had an idea, and I got a professor in the psychology department to sign on, that I would collect data of women's menstrual cycles because I knew about the Heisenberg uncertainty principle. Have you all heard about that? Has anybody heard about Heisenberg? He said that whenever you go to measure something, the tool you use to measure alters the thing you're measuring. So that what you think you've learned may be an artifact of the tool. It may not be real. And I thought, well, if women would keep a record on a calendar of when they menstruated, I didn't think there would be too much intrusion into their cycle. And I figured I was going to find out that the women who were more nervous had one kind of cycle and the women who were more calm had another, and I was wrong. But at the last minute, listening to what was happening with the rat sex studies that I don't have time to tell you about, but they were really interesting, I had this idea, and I asked the research assistants who were working with me, ask your student to put on her calendar what her assessment is of her pattern of behavior for coitus, for intercourse. She's never had intercourse during the 14 weeks that they've been keeping records. She's had some sporadic, or she never misses a week. She's weekly. When we plotted that data, the 60 people came out, the 60 dots, that all the weeklies were close to the 29.5-day cycle length. And you may imagine why I brought up the moon in the beginning, and that it says its cycle. It turns out a 29.5-day cycle is the most fertile cycle a woman can have. Those women who menstruate at every 29.5 days are 98% of them have a fertile cycle that time. The further away she goes from that cycle length, whether shorter or longer, the less likely that cycle is fertile, meaning should there be sperm provided at the right time, she's not likely to get pregnant. Sperm will live in the fallopian tube for 3 days. The egg lives about 6 hours. So the sperm has to be waiting, just like men have to wait for women. It's the nature of nature. It's the basic biology. The data here showed something startling, and my faculty in psychology said that I didn't belong in the psychology department. I belonged in the biology department, and they were correct. I went to the biology department and was very fortunate to have wonderful mentors there to replicate this study, not retrospectively, asking people at the end of a study, but to see what would happen if they kept records of their cycles, that's when they bled, and a cycle length. Let me explain that to you. A woman who gets her period, starts bleeding on January 1st, and then starts bleeding on January 30th, has a 29-day cycle. There were 29 days till the next cycle started. Doesn't matter if she bleeds for 3 days, 5 days, 10 days. The cycle length is defined by day 1. How many days is it to the next day 1? And that's what we really had accurate data on the cycle length. We just didn't have accurate data on the behavior. The next one shows you the data collected a year later of a very large number. And can we get to the caption? Is it 248 women? Yes, that's 248 women. Now you may wonder, why are there so few that meet the criteria of weekly? Because do you see how few there are that are weekly compared to sporadic women and never women? And that's because a condition for being in this study was they weren't taking the oral contraceptive and nor wearing an IUD. So sexually active women would be most likely to be preempted from being in this study. We were asking about natural cycles. The triangles, can you see the triangles versus the circles from where you are? The triangles, we asked, is twice a week more profound in producing, in associating? Right now we don't know what causes, what's the cause. Is the cycle length the cause of the behavior, or is the behavior the cause of the cycle length? We can't tell yet. This is just an association. We have a clue that if we knew that the cycle length is around 29 days, we don't know what the behavior is. But if we know the behavior is every week, we can predict there's going to be no short cycles, 2 studies in a row, and just a few long cycles proportionally. Let's see where we go from here. Let's go to figure 4. We asked, what about, is this effect, can she do it for herself? Would regular weekly masturbation do it? And the answer is no. It takes a partner. And you could go back and read that study and see it, but that's what that question was asking. Figure 5 showed the same pattern in, well, we have a bunch of different groups in figure 5. If you go further down, there's the big group. It doesn't matter whether we looked at the first cycle, we took only one data point for each person, or the average cycle over the cycle length over the 14 weeks, or the last cycle. We kept getting the same result. The same pattern kept emerging, which is that cycle, people who have weekly behavior have cycles that are more fertile in length. That's all we knew then. Now we're going to go to pattern recognition. You've seen some patterns here. We're going to go to the carousel that is on the Ursinus link, but not on anybody else's. And I want to take you through, these are 10, maybe 10 or 9 of the pictures I have in this book, one of the books I wrote called Love Cycles, The Science of Intimacy, showing you some of the cycles in nature. This is not my work. This is amazing work of other people. This is an array of 25,000 menstrual cycle lengths of women, and the data were collected over 3 generations of women. And what the data, this was Treloar's major work and published in 1974. I looked at that and I said, oh my goodness, look at that pattern. And what he was showing was that puberty, the first 7 years of menstrual cycling, and premenopause, the last 7 years, have a wide range of this. The vertical axis on the left side is cycle length, 85 days, 80, 75, down to about, looks like the lowest dots are around 16. Every 16 days, a woman's bleeding. And as you move into the years of peak fertility, you notice that the cluster of data get closer to the 29.5 days. He didn't consider that the reason that the women were having 29.5 days had anything to do with their sex life. But what he showed was the pattern. And perimenopausal, the same thing in reverse. I found when I went out to Stanford to set up the Stanford menopause study that women who were perimenopausal, meaning they were approaching their menopause, who had regular sex, did not, they had 29-day cycles. It delayed the onset of menopause to have regular sex. So that's the first one. Let's go to the next one. This was the same pattern. This is the first coital age by diagnostic condition of that first study I showed you. You see the 800 on the x-axis, the 792 women. The width of the bar is the group. And so this is this is primary infertility, the two with the highest age. This is the routine gynecology with the lowest. But the vertical axis is not years of age, it's chronological age since the first menses. This is growing up age. The mean gynecologic age of a woman who's 5 means she's been menstruating for 5 years. That for 6, she's been menstruating for 6 years. And what we found was that women who had waited till after their 7th year of menstruation were in the primary infertility group. It suggested a critical period of 7 years. That's the same 7 years that you saw in the Treloar data. If you go back one, that's a 7-year puberty period and a 7-year. There's something magical about the 7. Let's go to 2 more. Keep going. This is the magnificent structure of a woman's pelvic organs. And it shows you vaginal, cervical, endometrium, the lining of the uterus, and it's in exact proportion of a fertile age body. You see the tiny little ovaries with an egg, and the fimbria of the fallopian tube suck out the egg. They actually, we've seen movies of this where it's almost like a vacuum cleaner pulling the egg out of the ovary into the fallopian tube, where if a sperm has gone up and is waiting, he's got 3 days to wait, there's the potential for a fertility that will land in the nest of the lining of the endometrium. It is absolutely mystical, the exquisite symmetry of the female body and the cycles. Let's go to the next one. This is a cross-section of a slice of an infant girl's ovary. A baby girl is born with all the eggs she will ever have. Contrast to men, men produce sperm every day into old age. Women are born with baby girls are born with, it's an estimate of about 500,000 eggs in each ovary, about 1 million eggs. So this is an infant girl, and this is one big egg. This is, what you're looking at here is a follicle with the egg in the middle, a follicle. These are lots of follicles, cellular layers. You can read about that if you want in Love Cycles. Go to the next one, please. This is a 30-year-old woman's ovary, drastically different. Let's go to the next one. This is the cycle of a fertile woman. And it shows you lots of things that are happening across the time of the month. I want to take a quick course through what's happening. This is what's happening in the endometrium, the lining of the uterus that I just showed you. At the center part of the uterus, the womb is, just before menses, it's thick, and there's a big nest. It breaks off and bleeds out. And therefore the womb lining is very thin. It builds up, gets big, and another cycle starts. That's the repeating cycle of a fertile cycle of a woman. Meanwhile, in the ovary, one follicle grows and grows and grows. The egg is going to leave. I showed you the fimbria that'll pull it out. This tissue will reform into what's called a corpus luteum, a yellow body. Corpus is body, luteum is yellow, and early anatomists saw it. That's the manufacturing site for progesterone. It gets bigger, it grows for 7 days. It gets so big that it fills half the ovary. and then it starts shrinking, and the progesterone levels start dropping. And above it are what would, if you took blood every day and said how much estrogen and how much progesterone is in the blood of this fertile woman, you'd see this repeating pattern. 2 peaks of estrogen and only 1 peak of progesterone. No detectable progesterone before ovulation. And in the luteal phase, lots of progesterone. And those 2 are hormones that I don't have time to tell you about from the pituitary. Let's go to the next slide. This is about men. How do men's testosterone, men and women are very different. You probably all know that. And I think it's viva la difference, it's spectacular. Men's testosterone levels change dramatically with age. This shows you from a 10-year-old to a 90-year-old lifetime. What's the plasma level of testosterone? And the bars are the average, and look at the enormous variation of why do some men continue to have very high testosterone as they age, and others have very low as they age. It's an interesting pattern. Let's see what's next. And here's the annual cycle of births in the United States, in Louisiana, Maine, South Carolina. And what it's showing is there is a cyclic average annual cycle that has peaks and troughs that are the same no matter where they are, but more elevated in some places than others. Let's go to the next one. And there is another picture of the phenomenal hormone cycles and fluid secretion from the cervix. The same cycle that you see there, about 4 cycles, 4 repeats. This is an amazing pattern that's going on day by day. So if you want to know why you're moody or why you're brighter or why you're sleeping better, it's right in here. Let's go to the next. I think that's probably the end of that carousel. Okay, so let's go back to, now we're going to go to lunar and menstrual phase locking. And go to the results. In 1980, or 1979, my professor in biology said, you know, Winifred, you have all these data you're collecting of college women's menstrual patterns. Why don't you take a look at what's been shown on the moon? Is there any relationship between the moon and menses? And nobody had ever found it. Arrhenius in 1898, who won the Nobel Prize then for doing something with a kite and electricity in the sky, had published in German that he looked for it, he expected to find it and couldn't. And I thought about it and said, well, he didn't find it because he didn't look the right way. If a woman has a cycle that's, this is a circle, and I looked up on this is engineering paper, and I looked up in an almanac at the time, when is the full moon in that year? And that's the circle at the top. And when is the new moon at the bottom? And the first quarter and the third, see, it would be first quarter and third quarter, and got all the dates filled in. And I started figuring, I have all these data, how am I going to plot them on a graph like this? And if nothing's going on, they should distribute each woman's menstrual cycle. If we did 1 cycle per woman, there'd be just as many on one half of the month as the other, and that wasn't true of the women who cycled as often as the moon. There was about twice as many women cycling menstruating in the light half of the month than the dark half. Then we look at the next graph, said, but what about if you plotted everybody and all their cycles? You see nothing like Arrhenius saw. Because a woman who has a cycle, say, of 40 days, if she got her first period here, her next one's here, her next one's here, because this is a 29.5-day cycle. So 40 days, I don't know if you follow that, but you can read about it if you're interested in it. What's more interesting is the other one. A professor of biology wrote to me when he saw this, if you go back up to the top and go to the other study, he asked me, do you have any other data, because you didn't plot it very sensibly, and there's a much better way to analyze these data. And we had a lot of, you go all the way up above, that's it, you found it. So 7 years later, we published this study, which looked at about 6 different years of women's menstrual data and said, what is the pattern? So if you stop right there. This first one was the fall of 1976. Those women who had the 29.5-day cycle, and you see the average number, it's a moving average of women at the full moon, that's the circle at the center that's a hole, whereas the black is the new moon. And you see this pattern that keeps repeating in every group, lots of different groups. If you go down, this was a colleague at Brooklyn, Erica Friedman, did a study of her college students and found the same pattern. Let's go down further. This is another year, and it didn't matter. This is spring of 1983. And what we found was fertile women tend to menstruate in the full moon period of the cycle, and they tend to be ovulating in the new moon. It's the end of that. Now, let's go to, now we're going to go back to sex behavior and how it, go to a paper called Sporadic Sexual Behavior. Remember we looked at weeklies, sporadics, and nevers. This is a study that looked at the data of the sporadic women, and when we asked the question, is more sporadic behavior going to make the woman more likely to be a 29-day cycler or less? What would you guess? Would it matter? If you were going to do the experiment, this was what you saw before, only in a bar graph, and you have all those women who are sporadic. If you just said, how much sex did they have? Does it help make them be in the center of that, or does it hurt? Any idea? Any guess? Let's go to the next one and see what we found. Okay, this one looked at the weekly active women and said more coital behavior. All the weekly active women had at least 17 days of coital activity in 14 weeks. That's not surprising since it's a 14-week study and they never missed a week. And what we found here was more behavior didn't seem to have anything to do with what the menstrual cycle length was in weekly active. Now let's go to the sporadic. This is the sporadics. We found the same thing. The more behavior, they were just as likely to be one pattern. There's no pattern. What we found is that I think of it like feast and famine and anorexia and bulimia. Having a lot of behavior in a sporadic way is probably extremely unhealthy for a woman. We didn't know that yet, but I'm going to show you soon that that we had data to show that. It promotes infertility and aging and other problems. Okay, let's go to luteal phase defects. That's the next paper. This is a study from Dr. Garcia's infertile patient population. So these are all women who've come, they're infertile, and they have basal body temperature graphs. Have you all heard of a BBT, basal body temperature graph, or not? Is that, okay. You can go to the drugstore and buy a basal body temperature graph, a thermometer kit, and take your temperature before you get up out of bed every morning, record the temperature, and there will be a pattern if you're fertile, and there'll be a lack of pattern if you're not fertile. We were able to look at that pattern because all these infertile patients had kept records. And what we found was, first, the menstrual cycle length and the hyperthermic phase length. Means after ovulation, until the next period where I showed you the progesterone's rising, the corpus luteum is getting bigger and bigger, producing progesterone. That's the time of the month when the basal body temperature is elevated. So a woman who keeps her records of her temperature will find every day will be like this. When she ovulates, her temperature will shoot up, and every day after that it'll stay up and then drop when she gets her period. That is the pattern of a fertile cycle. And if it doesn't stay elevated for at least 12 and a half days, she's not going to get pregnant. She might ovulate, but there won't be a good enough nest. There won't be enough progesterone to build that nest that I showed you in the womb for an egg to implant. It'll just abort right out. So this we were asking, that's called hyperthermic phase length, the time when the temperature's hyperthermic, higher temperature. And we were asking, what is the hyperthermic phase length as a function of the menstrual cycle length, and break it down into weeklies and sporadics. And what we look at here is, look at the sporadics or the holes. The people with regular cycles who are sporadics, some of them have infertile, hyperthermic. The short cycler who's sporadic would never get pregnant. The long cyclers, the two long cyclers who are sporadic below the line, which is they don't have an adequate luteal phase as measured by their temperature, all those women are infertile. And the kind of infertility is a luteal phase defect. And I think it was 7 out of 8 of them were sporadically active women. That's what that study shows. The details we can't get to fast, so we're going to skip it. The basic theme of that was You can tell by your basal body temperature if you have an adequately long post-ovulatory time to be a fertile person. And for young people, it might matter, you don't want to get pregnant. But for your longevity, it matters tremendously, because fertility, the reproduction of species, the way it works is the fertile creatures are the healthiest. And when you get unhealthy, you become infertile. It's nature's design to prevent offspring being born to unhealthy people. That's the fundamental design of nature. And you can measure that fertility by your basal body temperature graph and see how healthy is my fertility system. You could see it by taking your temperature. Let's go to the next one. Now we looked at sexual behavior frequency and fertile menstrual cycle lengths. We're starting to get into much greater detail of how sex affects fertility, which affects aging, and then we're going to get to how we learned about pheromones, what made it obvious. Okay, here is coital frequency and cycle length. You've seen that before. But this is a subset. Let me make sure I have it right. In this study, we had, in 1983, 14 research assistants followed 120 students to get the data for 120 students. This first one is just showing you the overall pattern. And we see the same pattern in 1983 that you saw in 1979 and 1975. The next slide looks at the estradiol. Is that the, no, we're not up to estradiol level yet. We're looking at, I have to, what figure number is it? Can you tell? Is it figure 3? This shows that self-stimulation is not effective as an associate of the cycle length. We had another year, it's another replication, it didn't work. The next figure, that's actually table 1 is going to show you the basal body temperature graph, if we can get to, there it is. Okay, this is to me the best thing to look at for what this was showing about temperature. Weakly active women, there's 3 kinds of symbols, and each symbol is one person's data. It's her pattern. A plus is a fertile pattern. She ovulates and she has an adequately long luteal phase to permit a pregnancy. All the weakly active women had different cycle lengths, but all of the ones that are with the pluses are completely fertile, and the one with the lopped off right part of the plus, that's a luteal phase defect. So one of the weakly active women had a luteal phase defect. The sporadic women shows different cycle lengths, because this is cycle length, and that barred side is that 29.5 plus 3-day cycle length. And you can see the huge quantity of luteal phase defects in sporadically active women, and very few failure to ovulate. The very shortest cycle, the very longest cycle and the very shortest cycle of the sporadic, you see that minus? That person didn't even ovulate, and neither did that one. And the nevers similarly showed a lot of luteal phase defects. And what this was saying is that almost all weakly active women have fertile cycles, as measured by basal body temperature graph. And about half of sporadic and nevers have infertile. Feast and famine behavior does not associate with fertility. It actually is shown here to associate with mostly luteal phase defects. Deficient progesterone levels is what it turns out that they have. Okay, let's go to the next one, which is the last one in this series before pheromones, and that's the next study. That was the percentage, 90% of the weakly women are fertile. This is the one. Steroids. Does everybody know what a steroid is? Yes? Okay. This is a subset of, what we had here was a subset of 27 women from the 1983 study agreed to give blood 3 times a week, as well as all that other data. And they gave the blood in the luteal phase of the month. And these are the data of the 27 individual women. If we go down further, you go back and look at what that data showed, but I want to show you the summary of the data. Turns out that neither testosterone nor progesterone was related to the behavior pattern of being weakly versus less than weakly. but look at the estrogen level difference in the weekly active women. They're circulating 118 picograms per milliliter of estrogen. You see that? Can you see that number from where you are? You can. Okay, and the less than weekly, what are they circulating? 65. Menopausal women are about 40. So this is young women that ought to be circulating around 120 are not. They're about half as much estrogen circulating. It has a lot to do with an awful lot of health effects that you can expect from that. Let's go further. This is total estradiol comparing celibate sporadic to weekly. That's just a bar graph. Instead of looking at it I like to look at individual data, but most people like to look at bar graph summaries. Here's another one of that same set of people, looking at what was the behavior pattern. The X's are the sporadically active. Look at their estradiol levels. Look how low they are. Can you see all these people who have not too much sex? Their heterosexual total is 4 or 5 or 8 days out of 14. And look how low their estradiol levels are. And compare that to the weekly women. They're all much higher except one person. So this is what we were finding, and being celibate seemed to be a little protection. So it's like either do it or don't do it. But halfway effects are not real good for a woman's body, is really what the data were saying to me in terms of fertility. This is another, let's see what figure 3. The proportion of long and short cyclers who have deficient estrogen, that's really what it's looking at. And I don't have time to take that apart, so we're going to skip it. The summary of this whole study is stable sexual behaviors seem needed for optimizing levels of luteal phase estradiol, and testosterone and progesterone do not show up as related to the behavior pattern, even though it did show up as related to the cycle length, the luteal phase length. All of these studies taught me as a scientist that there's something about the dynamic of regular sex with the opposite sex for a woman that makes her fertile, that makes her estrogen levels high. We know that estrogen does amazing things for the brain, the bones, the cognitive function, the cardiovascular function, the blood. It's everywhere they've ever looked, estrogen is profound. And with aging, estrogen diminishes and the woman starts aging, her bones start losing mass, she starts having, this morning I read a study that as estrogen levels drop, your mothers and your grandmothers, if they're not taking hormonal replacement therapy, the fatty tissue around their heart starts to build up. And they think that may be part of why the cardiovascular disease starts rising dramatically for postmenopausal women. But estrogen is the amazing life source of femininity, and we see it's related to sex behavior. And she can't do it for herself. It takes another person. And it takes a stable, ongoing other person, not one guy here and one guy there and skip a week and go look and then find another one. It takes stability of the pattern to show these. And instability of the pattern messes up the system, is what we came to see. So we asked, what does a man provide for a woman that she can't provide for herself? And my colleagues and I at Penn, one was a chemist, he thought it was in the kissing gases. I thought it was in the underarm sweat. We just had a difference of opinion. I always noticed that the general thing in dancing was a woman was shorter than a man. Where was her nose when they're hugging and kissing? That's just what I thought. And we knew it was going to be somewhere. There was going to be something coming from the other. And is this the pheromone? Yeah, you got the pheromone study. That's great. Okay, so what we did was for this, the first set of we wrote to the National Science Foundation and asked for money to test both. And they only gave us enough money to test one. So we had to battle it out and use logic, and I won. You know, maybe there would have been some in the kissing gases because we never tested it. But that we definitely found in the underarm secretions of both men and women pheromones. So now I want to tell you what a hormone is and what a pheromone is, how they're alike and how they're different. A hormone is a substance that's produced in a gland. The ovary's a gland, the testes a gland. Can you name any other glands? Does anybody know any other glands in the body? Pituitary, good.
Pineal.
Pineal gland, can you think of any others? Thyroid gland, great. Each of those glands produces hormones. That's what glands are about. They're hormone factories. It also happens that each of the glands generally produce two hormones that in terms of the regulation, when one is up, it inhibits the other, and they have opposing effects for the dance of the human body. So a hormone is a substance produced in a gland, gets into the bloodstream, circulates, gets off, and has action elsewhere from the place it was produced. That's why I say estrogen made in the ovary has actions in the brain, in the breast, and everywhere. And a pheromone is a substance and that's an endocrine gland. Endo meaning inside, crying. The early anatomists saw what looked like tears when they looked at glands, and they saw tears. And they said, oh, let's call these endocrine. We don't know what they're doing, but we see these tears coming out of these glands. And those were the estrogen, progesterone. Those were the tiny substances that were the hormones. A pheromone is a substance produced in a gland that is external to the body, and it takes its action on another species-specific, conspecific. If it's a dog, it's other dogs. When a male dog urinates and marks his territory, he's dropping a pheromone all over the grass that tells other males to keep away. This is his territory. Humans, it turned out, in their underarms, we were able to collect the sweat from fertile. We only allowed fertile candidates to offer their sweat. We only allowed women who were sexually active and menstruating in the full of the moon, because there was something about the lunar cycle. So the donors of these substances wore underarm pads, came into a lab 3 times a week wearing no deodorant, only washing with ivory soap. They had stinky sweat pads. They gave it to a lab technician who dealt with it. And ultimately, these pads were put at the top of a tall column, filtered with alcohol through charcoal, which I was really happy about because I was worried about AIDS at the time. I didn't know where AIDS was being transmitted from, but I worried that it could be in the underarm sweat, and it was not, but we didn't know then. And what was happening then is we were collecting the underarm secretions of fertile women and attractive, sexually active young men, pooling them. For the women, it was a day 1, 2, 3 of their cycle pooled together, day 4, 5, 6 of their cycle pooled together, and they were then frozen for a year, in special jars, taken out a year later, thawed out, and applied to naive young women to see whether, versus placebo, the pheromone could be rubbed above their upper lip 3 times a week to get the effects that we already knew existed, and we were 2 different effects. For women who came into the study naive to test a pheromone versus a placebo, who said they had a 29.5-day cycle, they were sent to test female essence to look for menstrual synchrony. And you probably all have heard about menstrual synchrony, is that right or not? I can explain it if you haven't. Does everybody know? Would you nod? Tell me. Do you know about it? Okay. The question was, did the donor's day 1 sample, and then her day 3, 3 days later, and then her day 5, 3 days later, over the course of 14 weeks, did the recipient's normal 29-day cycle synchronize with the thawed essence from a year before? And the answer was yes, it did. And the other question was, how about the male essence? Women who came into the study, they were willing to test a pheromone, and they said they had irregular cycles. They were not 29-day cyclers. They were going to test the male essence to see whether male essence would cause them to become 29-day cyclers. This first graph shows those subjects who tested the male essence, who were initially irregular, long or short cyclers, versus placebo. And what we found was that the pheromone did, the stimulus, which was the pheromone, we didn't know yet that we could call it a pheromone, so we called it a stimulus. The stimulus applied of the male essence 3 times a week to those separate people caused their cycles to become closer and closer to a 29-day cycle, whereas the placebo users had no change, and their cycle length was not within the fertile range that you see that the stimulus recipients were. That was the first study. And this figure shows the last cycle of all the subjects. So these women had 3 cycles over 14 weeks. This shows the last one. Let's look at the next slide. This one shows if we took out the women who were weekly active sexually during this experiment and said, well, what about just the women who didn't have any sex on a regular basis? The effect got stronger. So we got the noise out of the system because some of the women entered the study with irregular cycles, but they got a boyfriend. And they started having sex, and the sex may have accounted for the being in the fertile range. And when we got only non-weekly subjects showing, non-weekly active, what we found was the stimulus recipients were much more inclined to be 29-day cyclers than the placebo users. Does that make sense? Are you seeing that, or is it too fast? Do you understand it? Would you either shake your head or nod so I know? You get it. This is a tremendous amount of material. And if you're interested enough, you can go back and read the studies. I'm trying to show you what we knew we found. And you can see the arguments that allowed it to get published and allowed the media to go crazy after it was published. Okay, the next, let's see if there's another, let's see how that works. Treatment of all subjects, this is the probability levels of the tests of significance of what I just told you about, showing that male essence caused irregular cyclers to become fertile type cyclers. That's what that slide shows. Let's go to the next one. I think that's it. Let's now go to the other study, the one of how female essence caused women who were already regular cyclers to synchronize to the donor thawed stuff from the year before. And what this is a figure of is showing you across 3 menstrual cycles for the 2 groups of recipients. So there's 6 points. The first one is in the first cycle, the 2 different groups, the ones getting placebo versus the ones getting female essence, have about the same days difference in their cycle onset of the donor sample that's coming to them. They're about 7 days apart from the donor day 1 when they get their first period. The next one shows that one group is starting to get much less distance from the donor day 1. Her cycle is moving, and the other one drops, it looks like it drops a little. You see a huge standard error, if you know what those vertical lines mean around the mean. By the 3rd cycle, a highly significant difference. The women who received donor essence from female, fertile, now we could call it pheromones, their cycles came into synchrony with the donors day 1, day 3, day 5. They're moved to get closer and closer to be and presumably by the next cycle it would have been even closer and closer, because that's what synchrony is, that women who live together start to cycle together. So women who got female essence started to cycle in phase with the thawed essence from the year before, from the day 1 and day 3. And that's basically what we had. All of these things led us to the conclusion that human pheromones do exist, and they do produce the effects that the behavioral studies had previously shown. Women who live together start to cycle together. Women who have regular sex with men start to have fertile cycles. And that left us to what we won't do today, but to the development of formulas. And I just want to tell you one thing that came out of this. After I left Penn and founded Athena Institute, I was looking at the data, because I love to look at data, and not graphs of summary data, but actual data points. And I was looking at the sex behavior data of the women who were receiving female essence. And I said, oh my goodness, look at what happened. They started having much more romantic contact with men than the placebo recipients. And I thought, wouldn't that be interesting if the female essence applied to women causes a sexual attractiveness in the women? And that's where we go from this stuff to what became the next stage of the research, to develop formulas to test whether women who tested pheromones, female pheromones, would have a more fertile, not a more fertile, they would have more romantic behavior. Would they start having more sex? Would they have more hugging, petting, and affection from men? Would they sleep with romantic partners more? And it turned out they did in double-blind placebo-controlled trials. And we had so many men who called up when we started selling this stuff and said, what about us? Don't you have a product for men? And my husband, who's sitting there, I said, I think I could come up with a formula for men. And he said, men? Why would we want to have men coming to Athena Institute for Women's Wellness to get any product?
That's not our name. It's Athena Institute for Women's Wellness. There are no men in the title.
Anyway, I convinced him that it was worth testing, and we created a formula to test for men, and went on a television news blip for 2 minutes, had a bunch of men who wanted to test it, and it did work versus placebo. So we now have 2 products that we sell, one for women and one for men, for the last 23 years. And the reorder business of it is startling and shocking of people who love it because it changes their lives. It makes them more attractive to the opposite sex. So thank you for your attention. It's a long run through. If you have any questions, you're welcome to ask them. Thank you.